Okay, the end of chapter 13 has to do with reaction mechanisms. And reaction mechanisms is a stepwise process in which an overall reaction occurs. And those stepwise directions are called elementary reactions. They are molecular, the definition according to the book is that they are the molecular event resulting in a reaction. Oops. And so the reaction mechanism is just a set of the elementary. So an elementary reaction is the step, and the reaction mechanism is the set of steps that's given to the event one. When you're doing this, you generate things called reaction intermediates, which is a species produced during a reaction but does not appear in the overall reaction. And so it's important here to realize that it's first. Okay, so basically if these are steps 1 through, say, 3, okay? First means earliest. As a product, and just as a reminder, a product is on the right-hand side of the equation. And second, which is the later, or latest, as a reactant. And this is going to be very important because we're also going to be identifying catalyst and its opposite. So to know where, you have to pay attention to where you first spot a species. Is it a product, which is on the right-hand side of the equation, or is it a reactant on the left-hand side of the reaction? Okay? And then the rate determining step is the slowest step. We're not really going to work with that at all. So here, for example, is a reaction mechanism of propionine and iodine. Okay, so this would be step 1, this would be step 2, this would be step 3, and this would be step 4. So for instance, when we're going to do this full problem, but basically what we're going to do is we're going to learn to add up, and the reaction arrow is basically an equal sign. And so on opposite sides of the reaction arrow, you subtract. Same side of the reaction arrow, you add. Okay? And so, like I said, this is actually a problem on another slide, so we'll actually do it there. And before we do that, I want to introduce catalysis. Okay? A catalyst is a substance that changes the rate of a reaction. The book says increase the rate, although, as I told you before when we were in class, it's not necessarily an increase, but a change. There are 2 different classifications of a catalyst. There's the homogeneous catalyst and a heterogeneous catalyst. Okay, so this right here is an example of homogeneous. They're all in the gaseous state. Okay, and so I have a reactant, reactants are blue. I have a product in red, and the catalyst is in yellow. Okay, and so since both the reactants, products, and catalyst are all in the same phase, it is considered to be homogeneous. Okay, heterogeneous is probably more common, and that's at least in chemistry and biology, homogeneous is more common. Heterogeneous is the catalyst is in a different phase. So again, this is the same color scheme that down here as a solid is my catalyst, whereas my reactant and products are in the gaseous phase. Okay. Now, what's important here when we go to identify these things is that, again, like a reaction intermediate, a catalyst first, or again earliest, is a reactant. Second, or latest, is a product. So it's exactly opposite of that of a reaction intermediate. So if you go back here again, okay, so the reaction intermediate, the first was a product, the second was a reactant. Okay, and for a catalyst, it is first a reactant, it's first a reactant and then it is a product. Okay, so we're going to do that as a problem. Oh, whoops, before we do that, this is just showing why it is a catalyst typically increases the rate of reaction. We have in red here, we have the uncatalyzed reaction. Okay, and so you see with the uncatalyzed reaction that the activation energy is very large. Okay, by adding a catalyst to this, we break this into 2 steps. And both of these steps have activation energies that are lower. And so it's much easier to get this to go forward because of the fact that this is so much lower. And that's why it typically increases the rate of reaction. Okay, now here's the problem. Okay, and so this is the same one that was on the other slide. Okay, so again, this is 1, 2, 3, 4. It says determine any reaction intermediates are present or catalysts are present. And it'll also usually ask you for what the overall reaction is. So basically, I want to go through one by one and check all of my reactants, because if I check all my reactants, I don't have to check all my products. And if it's somewhere else in the reaction, I can subtract them or add them. So I'm looking for this species here, and I'm going to look for them on this side, which it doesn't exist, and I'm going to look at it for this side, and it does not exist, so nothing happens there. H+, not here, but it's here, okay? And so this is on opposite sides. This is a reactant, and this is a product. So I have 1 and 1 of them, so they disappear, or they subtract to 0. And there's not any other H+ here, okay? So I have H+. So I'm going to make a list as I cancel these out, okay? And then we'll identify them in a minute. All right, I check this one, and again, if I go up, okay, this is the same structure as this, and this one's very similar. They're very minor differences here. But this is CH3, C plus OH, CH3. Okay. I look for this structure, and this structure is here and here. Again, they're on opposite sides of the reaction arrow, so I can cancel them out by drawing a line through them. So I have CH3, C double bond CH2, OH. Okay, I have I2. I2 doesn't appear anywhere else, so I leave it. I have the CH3, CH2I, and OH. And if I look, it's also right here. Okay, so I have CH3, C, I, CH2, I, OH. Okay, so I've checked all my reactants, and that's there. And by checking all my reactants, I don't have to check all my products. So now I need to go back and identify them. Okay, so H+. Okay, so where do I see? I see H+. Let me change colors here. We're going to use lots of colors. H+ is here and here. Okay, so in the earliest reaction, which would be number 1, where do I see it first? It's a reactant, and then later, or latest, is in a product. So by definition, this is a catalyst. Okay, we look at our next one, and choose different colors here. Okay, and I have this structure. This is very similar. I knew it was. Okay, and that structure. So in the top one, or the first one that it comes along, it's first a product, because it's on the right hand side, and then it's a reactant. So this is a reaction intermediate. Which gets really old writing it, and so I cheat and call this an RI. It's just shorter as abbreviation. Okay. I have this one, and it's here also. So I'm finding out, I've crossed them out, but I'm figuring out where they are. Okay, and so the first place it's circled is on the right hand side of the reaction, and the second place is on the left hand side. So this one is also an RI. And the last one, let's see what other colors I have. Purple, yeah, or black. I have this one and this one. Okay, again, in the earliest reaction, or the top, or closest to the top, it's a product, and then in the following reaction, it is a reactant, so that is also an RI. So I have identified all of those. Usually there's one additional step, which is to write the overall reaction. I don't have a whole lot of room to do that on this slide, but basically by doing this process of crossing them out to write the overall reaction, I just want to write down what has not been crossed out. So I'll write down here in kind of a condensed form CH3, CO, CH3. So that was the structure here. Okay, I come down. The next thing that's not crossed out is iodine. Okay, that's all that's not crossed out on the reactant side. On the product side, this was canceled, this was canceled, that was canceled, that was canceled. So only thing that's left is this CH3, CO, CH2, I, plus HI. So basically your overall reaction is everything that you did not cross out in the previous process. There will be another video following this that will have 2 more examples in it.